Assalamualaikum. This practical is about multinomial logistic regression. In this practical, um, we will base the example from the ATS UCLA website, but I did some modifications um, in order to, produce results that might be more relevant to us. This is the link to the source. And when you read the data, be careful with the codes of the variables. Pay attention to labels and levels of the variables. Sometimes I feel that software is more user friendly in terms of the coding of variables. Um, First, we will read data, and to do that, we will use read underscore data function from Haven package. This will read static data. You can also use foreign package. The function that you can use is read.dta. However, read.dta can only read static data up to version 12. So in this example, data set, you have these variables. ME is the outcome variable, stands for mammography experience, 0 for never, 1 within a year, 2 over a year ago. SYMPT stands for a variable, a predictive variable, which is the response for this question or this statement: you do not need a mammogram unless you develop symptoms. Strongly agree, 1, 2 agree, 3 disagree, 4 strongly disagree. PB is perceived benefit, a score variable from 5 to 20. HIST, the mother of sister with history of breast cancer. Codes are 0 for no and 1 for yes. BSE is a response to the statement: has anyone taught you how to examine your own breast? 0 for no, 1 for yes. And the EC is how likely is it a mammogram could find a new case of breast cancer? 1 for not likely, 2 somewhat likely, and 3 very likely. So first, I'm gonna load library here. Library here is a package that makes it easier for you to work with your working directory. So whenever you change your computer or your machine, will have less error to with regards to the working directory. Library Taribus is a function to load Taribus package. And you know that inside the Taribus package there are other smaller packages, ggplot2, dplayer, and some other packages useful for us to visualize data, wrangle data, and tidy the data. And then library Heaven again is a function to load the Heaven package, and read underscore DTA is to read the data set stata dataset which ends with .dta. The file name is mamog9.dta. And first, we would like to get an understanding of the data set which regards to the observations, the rows, and also the columns or the variables. So the dataset contains 412 observations or rows and 7 variables or 7 columns. So you see that all the variables are in double class variable, but you know that this or some of these variables do not reflect that they are actually numerical variables, but because during data entry they were coded like that, so when R reads the file, R thinks that these are numerical variables when they are actually not. They are categorical variables but coded or entered as number. So use summary to get a quick summary statistics for the data set. So we have OBS, which stands for observations. So we have 1 to 412. Is that we have 412 observations, and this is the outcome variable ME, which is coded as a number 0, 1, and 2. There are basically three categories. Remember, 0 represent never had mammography before, 1 had mammography within a year, and 2 had mammography but over a year ago. And then seemed also a categorical variable but coded as numerical variables. 1 for strongly agree, 2 agree, 3 disagree, and 4 strongly disagree, which was the response for this statement: you do not need a mammogram unless you develop symptoms, so on and so forth, right? So so what we need to do is next perhaps to get a very quick account of the outcome variables. So this is the data inside R. If you remember, when we read data using this function read underscore dta, this function read this data, and inside R it is named as dat.m1. You can give whatever name here. That's not necessarily dat.m1. Whatever name is all right here. This is the data set that stays inside R, inside random access memory, while the original dataset stays behind. Okay. So the dataset dat.m1, what we do next is a percent bigger than percent, which is a symbol for pipe. Okay, pipe. So what stages? Okay, from this dataset, next do this, next do this. All right. So it is a chain of function glued together with symbols collectively known as pipe. Okay, pipe number 1, pipe number 2. This dataset group the dataset based on ME variable and count how many or what will be the frequency for each of the category of ME. We have for category 0, 234, 104, and 274. Next, we would like to convert the numerical variable to categorical variable. So what we do is to take the data set, then mutate, create a new variable name as me2, which is created from the original variable me. We categorize it using factor function, and we labels this variable to never, within a year, over a year. Because me starts from 0 and then 1 and 2, so never will represent 0, within a year will represent 1, and over a year will represent 2. Can write the function levels dat.m1 $me2, which actually tells R that please tell me the levels of variable me2 in the dataset dat.m1, and it return never, within a year, and over a year ago. Just to make sure, can again run this function, but instead of using me, use me2, and you'll get similar results. So that's basically a way to confirm that transformation went all right. So let's do the same to variable hist. We create variable hist2 using a function mutate, and we labels these variables as no and yes. Why we start with no first? Because no, variable hist starts from 0 and then 1, so you have to put the category for the lowermost one first. All right. So this data set do this function, which is mutate, to create a new variable called hist2 from hist by using factor to categorize this and label this with this. All right. Again, we do this to confirm that we have done things correctly. When it comes to describing your data, you can use a few packages available in R. For example, PSYCH package or summary tools package. If you want to use PSYCH, make sure you have got this installed in R, and then load by using the function library PSYCH. Then type described, then the name of the dataset, and it will return this information, this what we call very brief summary statistics of your dataset. Right, you can try this. This is just a way of describing your data. And then next, for estimation, you can use VGAM package, right? And because I'm using the example from Applied Logistic Regression book, I need to wrangle a little bit the outcome variable to mesh what the book what the this book Applied Logistic Regression book by Hosmer and Lemeshow. So I need to tweak, wrangle, or convert the variable, the outcome variable. Um, in the book, the reference category is the never group, never group, and you know that the let us go here. Never group is the it's coded as 0, okay, or 1 actually, sorry, 1 and 2 and 3. So the smallest group will be the reference category, okay, will be the reference category, the smallest number. So the thing is that in VGAM, it uses the largest number as the reference category, all right? So what we need to do is we have to reverse this so that it never will become 3, and within a year we stay at 2, and over a year will become 1, all right? So we need to do that because the way VGAM package specify the reference category. So that's all what I do here is to take the data set and generate a new data set, sorry, a new variable named me3 using mutate, and I use the function fct underscore relevel or factor relevel, is that I relevel me2 to over a year, within a year, and never. So if we look here, never is 234, over a year 74. So now we want never to be number 3, okay? So never 234 be the last category. So this is for the original ME 234 0, and ME2 234 never. Now because of factory level, we change the level of the variable. Now ME3 never will be the last, or the biggest number. Start from 1, 2, and 3. 1, 2, and 3. You don't have to do this. Perhaps in your data analysis, I had to do this because I want to replicate what Hosmer and Lemeshow did for this topic in his applied logistic, or their applied logistic regression book. And then I load library VGAM. Then run the function VGLM. This is the outcome variable. Make sure you choose the correct outcome variable, okay? Because now what we want is the that never will become the reference category, and never should be should be the biggest number, right? So we start off with one predictor, is true. Then set the argument multinomial here. For argument data, set the parameter to dat.m1, the data set. This object, this analysis we want to save as an object called fit mlog1. Okay, so this function, we run it, and the results want to save as an object called fit mlog1. To see the results, type summary fit mlog1 and you'll get the results. Okay, so see there, the reference category for VGLM is the category with the biggest number. So we have changed the level of the outcome variable ME. So the ME3, the biggest number, represent never. Okay. So intercept 1 is over a year ago versus never. Intercept 2, within a year versus never. His 2 years 1 for over a year ago versus never, and his 2 years 2 outcome ME within a year versus never. Check the interpretation of the results in the lecture note. So we can estimate other model by specifying the predictors here, and you realize here that the results from multinomial logistic regression, this one, this is this will return the result from multinomial logistic regression. The results contain only log odds, right? Log odds without 95% confidence interval for the log odds, and there is also no odds ratio, and there is also no 95% confidence interval for the odds ratio. So to get that values for the confidence intervals and also for the confidence intervals and p-value, then we can do inferences, right? So what I do here is I use the function cof and conf_int. The cof will return results of the logos, and conf_int will return the confidence intervals for the 95% confidence intervals for the logos. Then what I do here is I bind those two results, so it becomes table. So this is the log odds, and this is the 95% confidence intervals for the log odds. Then to get that odds ratio or relative risk ratio, and what I did was to use the function exp. So I exponentiate the log odds. So I exponentiate the confidence intervals of the logos. Okay, and this is what I got, right? So this is the log odds. This is 95% confidence interval for the log odds. This is the relative risk ratio, and this is the 95% confidence interval for the relative risk ratio. I think I missed something here. I think what you need to do is to have another one, which is the exponentiations of this one, right? So you have to have one more exponentiation here. This will return the uh, relative risk ratio for the confidence intervals, but you also need the relative risk ratio for the log odds, right? So I missed that one, so I need to do one more here. Um, Next we go to a more complicated model where we have more predictors. So if you see here, I use VGLM, and this is the outcome variable, and I use a function here. I use a function here, factor SYMPT. When I use this, the R software will automatically convert this variable, numeric variable, to a categorical variable. So it's very handy. And you have quite a lengthy result. You have to be careful when it comes to interpretations of the results. Okay, but these are all the log odds. Okay, the log odds. There is the p-value here. There is no 95% confidence intervals for the log odds. There is no relative risk ratio, and there is no 95% confidence intervals for the relative risk ratio. So you have to calculate it, all right, by using exponentiations or exp, like yeah. Right, what's next? um what we can do, if you don't want to do this, if you don't want to do factor simt, this is another way of doing it. It means that from the data set, create a new variable named as YMPTD. So this will be the new variable which will be created by mutate function, where if SYMPT less than 3, will code that as less than 3. If it is bigger or equal to 3, then you code as this 3 or more by using function if else. Got this? Again, you run the VGLM function to estimate the parameters of the multinomial logistic regression. Inferences, this is the coef function will return the log odds values, and the confint will return the 95% confidence intervals values of the log odds. This one. What we need to do is to exponentiate this value, and this value to get the relative risk ratio and the 95% confidence interval for the relative risk ratio, or RRR. So this is what I've done to put the results of log odds and RRR in one table. And this is a functions where I used to name the columns. All right. If not, we'll return some fancy or some ridiculous name. Um, this is just packages that can produce more pleasant results in HTML format. You don't have to do this, okay? But it's nice to get this kind of results, okay? Clean and neat on HTML document. So library knitter and library cable extra. So what I do here is to use the function cable, then apply this on this results, okay? Then I limit the digits to 3, 1 to 3, significant digits of 3. Then I set the argument parameters for this. You have a nice, neat table compared to this, right? For prediction, use the function predict.vgam and which model that you want to predict and what do you want to predict. Okay, so this is the log odds, the predicted log odds for each observation of the. So this is how I prove that what you got from predict similar to what you'll be calculating manually. So this is the intercept, okay, minus 1.25 minus 0.95 minus 1.25 minus 0.95 and 1.009 1.25 1.009 plus 1.25. Okay, for the first observation, the HIST2 is no, means 0, so you replace this with 0, and what you have is minus 1.25, which is similar to this one, and minus 0.95 because this is 0 here, which is similar to this one. Patient number 3, or respondent number 3, hist 2 equally yes, so you have to times 1 here and 1 here, so you'll get minus 0.24 minus 0.30 minus 0.24 and 0.30. Okay, that tail is to predict the probability of the outcome. Can use the function predict.vgam. What model do you want to predict, and the type will be response. Okay, response. So this is the probability of the first respondent to have done ME over a year ago, within a year ago, and never. If you sum the rows, you'll get 1.00. To calculate it manually, for example, you want to calculate over a year ago, first observation, right? Minus 1.25, this one. Okay. 1 divided by 1 plus exponentiations of minus 1.25 plus exponentiations of minus 0.95. This one. So you get 0.59. And then this is for the reference group. Okay, for the which is the never group. Okay, for the over a year ago, group number 2, exponentiate of the value of this. Okay, right, and plus the 2. All right, so let us see again, right? So this is for group number 3, the reference group. This is 1. For number 2, you take the value of the log odds for category 2, and for group number 1 within the year, you take the value of the uh, category 1. Okay, so this this one. Okay, this is 1 versus 3, and this 2 versus 3. Okay, so you get 59.8%, 17.1%, 23.1%, which is similar to this one, right? You can also use the multinom function from nnet package. Um, what are the differences between VGLM and multinom packages? One thing is that you can also use this function relevel to change the reference category. Okay, this is something that you can do without using factor that I showed you before. Okay, and this one for nnet or the multinom function, it will use the you specify the reference category here. Okay, you specify the reference category here. Okay, and nnet and multinom will get it. Will estimate the uh, the value of the logos. But I don't what we call I don't usually use multinom. I think VGLM function is good enough. And one other thing is that you won't get p-value from multinom. Okay, you won't get p-value. So how to get p-value, you can use this function, the 1 minus p norm. So you have to do something else to get the p-value. And this is the way to get confidence intervals for multinom functions in nnet. And practical number 4 is optional. Okay, practical number 4 is optional. Right, I think that's all. That's all. So have a go at this practical. Thank you.